Awesome, thank you very much. So I'm going to put this full screen. Hopefully you can see my screen.
Perfect.
So yeah, this is a session I wasn't expecting to give 24 hours ago, but it snuck in at the last moment just because unfortunately we had one person pull out for unforeseen circumstances. So this is a bonus session which is around securing containers, and we're going to be doing some live hacking as well. I may be a little bit quieter than usual just because I've been told that if I wake my kids, I'm in serious trouble right now, and it's just gone 5 in the morning. So if you hear a grown man crying, I've been too noisy. A little bit about me before we get started. I'm very heavily into my community focus. So I founded the Virtual Jug maybe 6 years ago. We have almost 17,000 people there. So if you're a Java developer, then that's a great place for you. Also, if you're in London and a Java developer, we have the London Java user group, which I'm a co-leader of. I'm also a co-leader with Sammy on my DevSecOps and a number of other people as well, which is a security and DevSecOps focused meetup group, which is available for free for great sessions like some of the ones that you've seen today or yesterday on this conference. Tammy, who's also on the helping with this conference, runs DevSecCon, and I'm a part of that as well, which is a physical conference, and there's some other stuff there as well which I do. But my role, as Sammy mentioned, was in the developer relations and community group at Snyk. Very, very pleased to be here today to talk to you about how we can secure containers, but let's talk about it a little bit wider to start off with, about the cloud native space and how we can think about kind of securing cloud native first. So when we think about how we deploy apps to a cloud platform, for example, in history, we tended to do that more as monoliths. And when we pass things as monoliths, we have a number of large host VMs which contain large apps which sit on top of a single operating system, and there are a number of functions in that app. You might actually have one app with one massive function, like the kind of do some work or do to do kind of function, but typically it's not broken down into microservices. However, actually, before I say that as well, you see the split here between what is done by the cloud platform and what is done by the application. And the application here contains everything that you would have in the host VM almost. And this is kind of like the split of responsibility between the vendor and the people who are putting things onto that VM, which is you as a user. Now, when we move to a world of containers, we can still scale our VMs there, but we have containers within those VMs, and the containers within the VMs have their own operating systems. You then have apps or functions within those containers, and it lends itself more to a microservice kind of style. Within that, you can have a container orchestrator, maybe Kubernetes or something like that. But into the platform, you actually get much better hardware utilization. And what we mean by that is, with the ability to have multiple containers, you use more of the VM with the ability to scale certain containers, but leave others, as they are. You have the ability to use more of the hardware that you're sitting on. Plus, you do have more OS flexibility because you don't, in the previous one, have one OS. You can have different OSs based on each container. You obviously have better cloud portability because you're coding to the container, and as a result, you can move those containers around with less trouble than if you were to move your functions directly, your apps directly into different containers that are native to those containers. Better elasticity as well, because of course you can grow containers or remove containers much more granularly. And then when we move into even further into a serverless kind of space, you're actually just writing code, you're writing functions, and those functions scale, and you're effectively just dropping code with configuration. And it's the configuration there which is more directly linked to the serverless vendor that you're using. Now, everything is then pushed down into the vendor. So the vendor takes care of the operating system, the host VMs, which can obviously scale. All you care about is the config and the applications. So you don't have to worry about the hardware management. no OS management, host setup, the best cloud portability, because other than the configuration, which may be more vendor specific, you can just move code around. And of course, you have the maximum elasticity as well, which ultimately means as you have demand for the code, for the different functions, the different functions can individually scale. And now we're going to be focusing on this middle one, the containers, and work out how we can kind of learn some tips about how we can go through different security, potential security vulnerabilities or security issues in and around our configuration. So let's go through a number of them, and we'll talk through how we can improve ourselves. So one of the first ones that we're going to be talking about is preferring minimal base images. And what do we mean by this? Well, a base image or a parent image, we very often don't pick because it fits the exact purpose we need. We very often pick it because it exists, or it exists and is easy to get, or it exists and we inherit it from our parent image, which goes all the way up to the base image that we use. And one of the things that we need to realize is we need to be leaner about how we pull things in to our production, and that includes the Docker base images. Now, if we look at the number of vulnerabilities that exist in open source Linux distributions, we can see that steadily increasing, and very, very heavily in the last 5 or 6 years alone. And a lot of this is due to the popularity of containers being thrown around and it being another attack vector for people. Now, it's very interesting here because we obviously potentially can expect, containers, because they're being spun up and removed so quickly. You would think that's maybe not the case because, previously you would think it would be slower to upgrade operating systems because people are running much closer to the bare metal and are less likely to necessarily, spin those up all the time. So they're more likely to get stale. But here we can see a large number of vulnerabilities steadily increasing. And when we see the number of vulnerabilities that exist in Docker images and Docker containers, you can see this is the top 10 Docker images. This is actually a little bit old, these stats, probably about a year old. But today's numbers are actually very, very similar. I think the top 10 are still 30 and above, and Node, I think, has dropped a little bit. But the key thing here is you have to understand that your Docker containers are full of vulnerabilities, OS vulnerabilities. And while some are going to affect you and some aren't, they're potentially, the majority of them are maybe in pieces of the OS that you're either not using or don't need to have for the success of your application to actually run on it. So choosing your base image carefully, and we'll look at this in a little bit more depth later, choosing your base image is very, very key. One of the other things that we're going to talk about here is the least privileged user. And what do we mean by this? Well, when we see a number of users running as root, we think it's the cliche, oh yeah, surely no one will do that. But one of the key things is in a Docker file, if you don't specify a user tag or a user, what do they call them, directive in your Docker file, then it will actually default to root. So the default in a Docker file, if you don't specify a user, is to provide all the privileges that are accessible for as a root user. And what you want to be doing is selecting the least privileged user. And the security idea behind this is provide people with nothing and build up as required. So when we think about what user we want, a great best practice is to create your own user or your own group. And here you can see I'm creating the user SJ Maple and a dedicated group just simply by using the user directive in the Docker file. And this is going to create a system user with no password, no home directory, and no shell. We can add this to an existing group that we created beforehand, and here we're using group add to do that. And yeah, this is pretty much straightforward. There's nothing magic here, but by adding this directive, we're making sure we don't provide, if something did happen and something we did get an exploit, we didn't actually provide people with the world. We provided people with a really limited set of things they can do. And of course, if you're a Node.js fan, I'm not here to judge. If you're a Node.js fan and you like Alpine images, there's a great generic user for you that you can use already set, which is called Node. So here's the kind of Node.js example, which makes use of that generic Node user. Okay, so provide the least possible permissions, and if you do get breached or you do get hacked, you're not providing as much authorization as you require for that attacker. Okay, number 3, sign and verify images to mitigate man-in-the-middle attacks. So man-in-the-middle attacks is where some malicious party exists between you and the artifact or the resource that you're trying to get, and as a result, it can intercept the file, the resource that you're trying to download, potentially manipulate that in such a way maliciously, and provide you with an untrusted resource which you believe to be real. So we put a lot of trust into these images, and a lot of the time they're going to be the code that's going to be the code that we run in production. So it's really important to make sure that what is pushed by the publisher is the code that we are actually using. So one of the things here is to prefer the signed images, and here you can see on Docker Hub you can search for a Docker certified image, and these are signed images. There's not too many of these because a lot of the time you don't necessarily see all publishers signing as they go through, but we can sign images fairly straightforwardly using Docker Notary, and these are the docs here for Docker Notary. And Notary verifies all the image signature for us, and stops you from running an image if the signature of that image is invalid. And there's a couple of things that we can do here to also test what you're pulling down. And one of the ways of doing that is to enable Docker Content Trust. And this is a really nice way of experimenting with the verification and validating that what we're pulling down are certified images. You can temporarily, if you wish, enable Docker Content Trust with that command there that I'm showing, the export Docker Content Trust equals 1. And what that will do is it will stop you from pulling an unsigned image. So that pulling down an unsigned image would fail. And you can see just by running with that, which parts of your build are failing. So making sure that you have trusted content to eliminate that issue. Next up, find, fix, and monitor for open source vulnerabilities in the operating system, and this is really crucial. So this is what I was talking about a little bit previously, and we're going to go into a demo here with a live hack. When we think about when people actually test for this, the sad thing is half of the people don't actually test for this, and only 19% of people test during development. And of course, there exists tools and there exists free tools. I'm obviously going to be showing Snyk here, but here's an example of how you can test. In this case, the Docker Node 10 image passing a Docker file. This is how you can scan a Docker file to provide you with the list of vulnerabilities that exist in that image. The second thing is, after that, this is just going to tell us the images that the vulnerabilities that we have in that image. The second thing is, well, what happens if a new vulnerability comes around that I don't know about, that is after my testing? What happens if a new vulnerability comes around that in a container that I've already deployed? Well, one of the key things here is that almost half the people probably won't even know that a new vulnerability exists. And we can, of course, use, again, free tools here to show how you can do a monitor. And what a monitor will do is it will provide you with an email or whatever, however you choose to consume these notifications. It'll provide you with the information that a new vulnerability exists and affects your current deployment. So having the insight of which vulnerabilities exist before you go to production and if you can fix them, as well as when new vulnerabilities come in, is extremely important. Now, because we test a lot of Docker containers and we test a lot of app code as well, we have a number of insights which we can share with you based on what we see from the scans that people are running. So this isn't necessarily across the entire ecosystem. These are just the scans which people come to Snyk for. So interestingly, 44% of Docker image scans have known vulnerabilities where there were newer versions that had a more secure base image. And this is really interesting because I totally agree with Baruch on the last session as well, in that you don't necessarily want to constantly stay with latest, because you don't necessarily know exactly what's coming in, and it's one of those kind of hard things to do. But equally, you don't want to be sat on such an old version that you're constantly getting newer vulnerabilities in, and you're just staying on that version without picking up the fixes that exist in the latest version. So there's a real balance between that. And one other thing here is, and this is where that balance exists, 1 in 5 of Docker images that were scanned, they can reduce the number of vulnerabilities just by rebuilding that Docker image. So by rebuilding the Docker image, you'll pick up the newer OS dependencies, and you will you'll effectively reduce the number of vulnerabilities. So there's a complete balance there that you need to be able to use. Now, of course, a good step here is to use that minimal base image, because using that minimal base image will reduce the overall number of vulnerabilities, because the overall number of packages that we have it doesn't exist. Now we're going to do a live hack here, and we're going to be talking about one specific vulnerability which exists in an ImageMagick package. And many of you who are familiar with containers and familiar with OS vulnerabilities will have likely heard of this package before. And we're going to be talking about this attack vector where we can pass in an input that provides that is not validated, and we can effectively break out of that and then start hacking our environment. So let me just pull this up. So okay, I'm going to come. Oh, actually, look, there's the. Let's give you a behind-the-scenes tour of what we're using to. Oh, look, there's Sam. There's Sam over there. This is what we're doing to stream. This is called StreamYard. It's part of the behind-the-scenes tools that we use, and I can from here show you a whole bunch of things. What shall I do, Sam? Shall I know I'm going to put a banner up to say. Should we say we're having some difficulties? Stay tuned. Yep, there we go. We can say let's donate. Let's have everyone donate. Awesome. So this is the really nice. Let's bring Sammy in, shall we? Hey, Sammy, how's it going?
Hello.
How am I doing, Sam?
You're doing wonderfully. I was just waiting to see something interesting, and then you got distracted.
And it's like, oh, finally, some an interesting speaker. Awesome. Well, I'll remove you for now, and we'll talk with Sam in a bit. But okay, you don't want to see my Slack. Okay, here we go. So this is what I want. So here we go. We have a Docker container. If I cat this Docker file, you can see we're running off Wheezy, Debian Wheezy, which is one of the vulnerable versions of which has this ImageMagick issue. We're just going to pull down. We're going to do an npm install, and we're going to run npm exposing a couple of ports. So for here, all I need to do is just run Docker, and we'll pull that up. Hopefully, I've got Docker. Daemon running. Okay, so we have that running, servers listening already. Now if I come over to let me just get rid of this so you don't have to see that every single time. Okay, so and I'll jump over to this one here. If I refresh this, you can actually see this running. This is our application, which is running in the Docker container. If I choose a file here, let's grab let's grab the sponsors. So if I open that file up, all this is going to do is it's going to convert it to a different size. Okay, and this is part of what ImageMagick does. If I resize that, there's our sponsors. Thank you very much to our sponsors. Who do we have there? We have Rapid7, we have Trend Micro, we have IBM, Atlanta Jug, New Relic, Snyk, the new stack, Okta. Thank you to all these wonderful sponsors, and we can basically just resize this. So that's all great, but let's do something a little bit more interesting. If I do an ls here, I'm going to actually pass in something like this, and let's cat this so you can see what's in here. So I'm going to actually do some regular stuff. I'm going to fill. And here's a URL, but look, I'm actually going to break out of this, and I'm going to touch a new file called RCE1. So let's, in this case, run this and see what happens. So if I come here and I say, yes, let's indeed add another file, and in this case, oh no, I'm in the wrong place now. Let's come here. Let's go over to the Sam again. Let's go over here and into my file, into my exploits, and run RCE1. Let's do a resize of that. Image success, we don't actually see a file here, but let's jump into my Docker image. So we're just going to do an exec just to get a console. And here, if I do an ls, all of a sudden, if I was to do an ls -1, it's 35 minutes past the hour. It is indeed. We can see that file has been touched. Okay, so this time, let's do something a little bit more interesting. Let's cat RCE2. And here we can see what we're going to do is we're going to do a wget, and we're going to grab a file that is being served called r.sh. So here what we're going to first do is in this directory, which is the exploits directory, we're going to want to share, we're going to want to serve this file. So let me do a serve dot, and now this is going to be working just fine. There you go. I'm telling everyone to update, and look, there's my update available. So here now we're going to be pulling in this r.sh. So we're pulling in a potentially malicious file. Let me have a look at that r.sh. And what's that going to do? Well, it's going to wget netcat. We're going to extract it. We're going to run it. We're going to make it and run it, and we're going to ping something a port 3131. Let's go and make that available. Netcat running now 3131. This is just sitting here listening. Yeah, that's pretty much all we need to do there. So if I just do an ls there, you can just see RCE1 is there. There's nothing else there, no netcat or anything like that. So let's try and actually run this now and see what we can do. So let's, yes, indeed, run that and run RCE2. Let's resize. It seems to just be spinning. I wonder what it's doing. So let's come back over here and have a look what it's doing here in our Docker container. If I do an ls, well, look, it looks like we've got netcat. We've instructed it, we've untarred it. It's most likely running right now. It has to come over here to my local. This isn't running in Docker. This is just running on my local machine. And let's type ls. All of a sudden, we've effectively got almost like this reverse kind of proxy, reverse shell into the container. So from here, from my local machine, let's just do some interesting things. Let's do a ps-ef. There we go. There's processes running on that container. Let's do an ls of /etc/password. Let's see if we've got some. Oops. Oh, let's do a cat of etc/password. That's what I really wanted to do. Sorry, it's still early here. There we go. There's our etc password. So now we can see this really interesting hack straight into this environment. So a couple of things then. Let me jump back here to this presentation. Couple of things. How long have we got left? Let's have a look. We've got about 15, few more minutes maybe. So here we have improper input validation. We've got a number of things here that we could do. If we don't need ImageMagick, we can remove the package. We maybe find a slimmer version that doesn't have this. We can maybe remove it. We could maybe go to a different base image that has fewer vulnerabilities. There are a number of things that we can do here. So let's do a few more before we finish. Use a linter. Linter is a very, very important thing as a developer to use. Here we have HaloLint, and HaloLint can look at our files, like our Docker file, for example, and it can tell us to say use copy instead of add for files and folders and things like that. Very, very useful things that we can do. Another thing we can do is find and fix vulnerabilities that exist in our open source libraries as well. I can give you a quick demo of that towards the end if we have time. But one of the key things here is that because our containers are much better at keeping up to date with our OS, attackers are targeting the OS less, and they're targeting our applications more. So as a result, what we can see here is the code that you write is very, very small compared to the application that you deploy, and that application can contain direct and transitive dependencies. And we can see the number of packages which are indexed in the different open source ecosystems is growing massively, and we're well over 1 million now in NPM. And dependencies exist both in our transitive dependencies as well as our direct dependencies. And here you can see, largely specifically for NPM and Maven, we have more vulnerabilities here in our transitives, and that is largely because we have a larger number of transitives than we do in direct dependencies. So it's very, very important to understand all the packages and all the dependencies that we're pulling in, as well as where the vulnerabilities exist that we also pull in. Okay, not too many more slides. One of the things that here that we can suggest is to also use multi-stage build for small and secure images. So what this is talking about really is the idea that when we are building our image, we do a number of things before we are ready to go to production. And if we take something like Golang or Java, for example, we need to be able to build that application first. That could include compilation and other things. Now, the compiler will obviously produce us some executable that can run on a virtual machine on an operating system. Sometimes without dependencies, but this is a good reason for why Docker has this kind of multi-stage capability. It allows us to select which kind of artifacts and files don't really exist, or you don't really have a reason to be in production, and as a result you can have multiple temporary images that you can remove during the build process. So you only keep the latest image with the information that you want to copy into it, that you want to push into production. So you might have a couple of images here for a Golang Docker application. One, which is a large image built with lots of dev dependencies in order to build your application and run your tests to make sure everything is ready to go to production. But image B is a much thinner application, a much thinner image in terms of just the footprint and the number of libraries that you deploy into it. And it only has the artifacts required to run that application rather than build that application. So in summary, there are a number of things here that you can do, it's important to at least think about all of them and understand which ones and how you can add this into your pipeline. But at that stage, given that we've only got a few minutes left, I'm happy to take any questions. And in lieu of questions, I can obviously show you another hack. So let me pass over to Sammy and.
We actually don't have anything specific on the channels at the moment, but if anyone does have a question, to bring them in. But if you want to show the simple hack while we wait, we've got 3 minutes. Can you do it in 3 minutes?
I can try.
Let's try.
What I need to do first is I need to do a let's do a Docker compose. Okay, so let's bring this Docker container up, and what this Docker container is going to show us is let me go back a couple. What this is going to show us is a nice little application, which is going to be running on 3001. I think it's there. There we go. It's a Goof application, and this is just a regular to-do application. But what we have is something which is serving us some HTML from this public application. I've already actually scanned this application in, and if I look for the directory traversal, here it is, directory traversal in ST. This is the package which is serving us this file. So what we're going to do is we're going to traverse the directory. So we're going to traverse this public directory to try and get to a space that we shouldn't have access to. So this is going to be a hack to view the file system on a Docker container, whereby we're accessing it through the application. So previously we were doing it with an OS package. Now we're doing it with an application package. So if I curl, let me make this a little bit bigger. If I curl that same address, got 2 minutes left, just under 2 minutes. So if I curl that, you can see that's the same HTML that we just showed, 1 minute left. But I'm going to do a directory traversal, so I do a .. We can see that the ST package has recognized we're doing a .. So we can see we're at the home page. So the thing here which we need to do is represent these dots as %2e, %2e, and this is going to represent the dots with a URL mapping, and now you can see we've broken out of that public, and by doing that I can now have a look at my package JSON that exists in the application. I can also continue that all the way back if I wanted to. Let's see which user we're in, all the way back to the root, and then have a look at my etc password. And there's our etc password. The fix for this is actually pretty simple. All we would actually need to do here is upgrade to a 025, which I can do automatically by creating a pull request, or I can actually, and this is just using the Snyk free tool, or I can choose to do that manually. But that is my 2 minute hack. Sammy, I was about to say over to you, but I think it's over to me now, right?